I would like you to reflect about the different types of data that we can encounter in healthcare settings and in mental health care settings in particular. Now, for each type of data that you listed earlier, I would like you to think about the characteristics of this data. In healthcare, we can encounter many different types of data. We can find self-reported data, often recorded through questionnaires. These have been the data typically used in research and in mental health, and it's still very useful in mental health, particularly when we talk about constructs that are subjective by nature, like how do I feel today. But nowadays, more and more, we have access to routinely collected data, which is data that is collected every time we present to healthcare services. So this could be in the shape of free text through clinical notes, or it could be more organized or more labeled through codes, coding systems such as ICD and SNOMED. We also have specialized data, so like lab tests and imaging results. And again, also nowadays, more and more we start to use and have access to data recorded through wearables, which will give us information about movement, about heart rate, and many other sensors. And all these different data have different characteristics, and therefore it's not straightforward to gain knowledge about all these different modalities of data. But we do need, if we want to include this data in our research, it's important that we understand the data and that we know how to process each of these data. Now, what are the characteristics of health data? Well, the moment we focus on one health condition, then the first thing that we're not going to notice is that we have more people without that health condition than with that health condition. And that's what we call imbalance in the data. And it's something that we need to keep in mind when we're building machine learning models. Health data is also biased. We know that, unfortunately, not everyone in the population has the same level of access to healthcare or has the same behavior towards seeking help. And it's also subject to privacy concerns more so than other type of data. Now, if we focus specifically on mental health, then the types of data that we can encounter here are even wider. So it's not only data that is generated in healthcare settings, but it's also social data, it's also economic data, educational data, etc., etc. All these different domains of data could be of interest for us when we're doing research on mental health, which again adds to the complexity of basically gaining the skills to be able to process all these data appropriately. And then I have highlighted here now the properties of, or the characteristics of, biased and privacy concern. And this is because we know that mental health data suffer more from bias than other types of health data. We know that those suffering from mental health conditions are less likely to seek help, are less likely to participate in research, and then when they do, are more likely to drop out halfway through. And also, they are subject to unconscious biases by clinicians, and that can affect the type of information that is recorded about them or the type of diagnosis that they receive. And And this is because there is a lot of stigma still nowadays around mental health, which again, it's why there are heightened privacy concerns around mental health data. So again, these are all things that we need to keep in mind when we are processing mental health data. Now we can classify data into two big groups, unstructured and structured data. In the unstructured data, even though the data contains the information that we're interested in, we don't know where that information is within the data. So the information is there, but we don't know where exactly, and potentially we don't know in what shape. So an example would be the free text in clinical notes. If we are looking for, say, prescriptions, we don't know within that note where the information about the prescription lies, and also we don't know how exactly that information is going to be recorded. On the other hand, we have structured data, where the information is very organized. So, for example, if we're thinking of a table will be a good example of a structured data. And here, if we're looking for the height of a patient, then we know that we can find that in column 3, for example. In this course, we're going to focus on structured data because this is the type of data that most machine learning algorithms consume. Some machine learning algorithms can consume unstructured data, but these are the least common by far. The reason why they can consume unstructured data is because they incorporate often a module earlier on that is capable of adding a structure to the data. So it's capable of finding the information that we are interested in and then organize that information, and then that will be passed often to another machine learning algorithm that consumes now structured data. So we're going to focus, as I said, on structured data in this course. And then in structured data, we can identify multiple parts. So again, think of this as a table because often this is what we have. In this table, again, as every table, we have rows and columns. Rows represent samples. Each sample could be a different person, a different patient, but also each sample could be a different event for the same person. So these will vary between data. And then in columns are the variables that we are going to look into, that we are going to analyze. So in the context of machine learning, we call these variables features. In the context of mental health, we call these variables risk and protective factors. And in the context of statistics, we call these variables the independent variables. Then you can see there at the table, the last column often is what we want the machine learning to output based on all the input features. So this is what we call in machine learning the targets. This is often in mental health research is the outcome of interest for us. And in statistics, this will be the dependent variable. So if we take only one row of features, that's what we call a feature vector. And as I said, usually the objective of machine learning algorithms, not always, and we will expand on this later, but usually is, given one sample with there is a feature given a feature vector or one sample of these features, I want you to predict this value, which is the target. So now, can unstructured data then, based on what we have said, be directly consumed by machine learning algorithms? So as we said, yes, some machine learning algorithms can consume unstructured data, but they are the least common. And Often, this algorithm will consist of two blocks. One that adds a structure to the data, and then the other one that is a more traditional, if you want, machine learning algorithm that consumes only structured data.